Let's now see if we can balance a chemical equation with slightly more complex molecules. So here we have a chemical equation describing a chemical reaction. This is actually a combustion reaction. You have some ethylene right over here in the presence of oxygen, and you need to get a little bit of energy to get this going. But then you're going to have this reaction that's actually going to release energy as well. But we're not accounting for the energy, at least the way we've written it right over here. You have some ethylene, and this little G in parentheses says it's in the gas form or gaseous form. So gaseous ethylene plus some dioxygen molecule, which is the most prevalent form of oxygen molecule that you would find in the atmosphere. And so that's also in the gas form. Put them together, you end up with some carbon dioxide gas and some liquid water. This is the classic combustion reaction. But now let's think about how do we balance this thing. Let's make sure we have the same number of each atom on both sides. And when you see something more complicated like this, where here I have an oxygen in two different molecules over here, and a lot of these molecules have multiple elements in it, it might be very daunting. Where do I start? And this is where the art of balancing chemical equations starts to come into play. The general idea is try to balance the molecules that have multiple elements in them first, and leave the molecules that only have one element in them for last. And the idea there is that these are harder. They're going to have all sorts of implications. And then at the end of the day, you can just set a number here for the number of dioxygens. If you saved, say, the ethylene for last, then every time, and you're trying to balance the carbons, then when you try to change the number of carbons, you're going to change the number of hydrogens, which is going to change you're going to have to balance over and over, and you're going to go into this really, really, really confusing circle. So the best thing to do, try to balance the complex molecules first, and then save the single element molecules for last. So let's do that. So let's start with the carbons. So over here, I have 2 carbons. Over here, I only have 1 carbon. So it seems like the best way to balance it is I should have 2 molecules of carbon dioxide. And I haven't even thought about the oxygens yet. By putting that 2 there, that's going to change the number of oxygens I have on the right-hand side. But at least it balances my carbons. I now have 2 carbons on the left-hand side, and I have 2 carbons on the right-hand side. I'm no longer magically destroying a carbon atom. All right. Now let's move on to the hydrogens. And remember, what I said is let's wait to do the oxygens last, because we have a molecule that only contains oxygen right over here. So we'll save oxygen for last. So let's do hydrogen next. So hydrogen, right over here, we have 4 hydrogens. And on the right-hand side, we have 2 hydrogens. So it seems like the easiest thing to do to balance the hydrogens is to have 2 of these water molecules. Now I have 4 hydrogens here, and I have 4 hydrogens there. Now let's do the oxygen. I've balanced the carbons and the hydrogens. And the reason why oxygen is going to be interesting, I can just count the amount of oxygen I now have here after after changing the number of molecules I have. And then I can adjust this accordingly, because this is only going to affect the number of oxygens that I have on the left-hand side. Well, right now on the left-hand side, I have 2 oxygens. And on the right-hand side, actually, let me count this. I have 2 O2s, really. So this is going to be 4 oxygens here. And then I have each of these water molecules has 1 oxygen, but I have 2 water molecules, so this is going to be 2 oxygens. 2 oxygens here. So on the right-hand side, I have 4 plus 2 oxygens. So I have 6 oxygens on the right-hand side. I need 6 oxygens on the left-hand side. I need this number to be 6. So how do I do that? Well, I just need 3 of these molecules. If I have 3 molecules, each of them have 2 oxygens, I'm going to have a total of 6 oxygens. And just like that, we have balanced this combustion reaction, this chemical equation.